Hello, today we're going to take a look at limiting reactant. And there's the chocolate chip cookie recipe again. Many of you, when you were watching the video that I assigned earlier in March, you caught on to the fact that the limiting reactant was the first one used up. I hope today drives that point home. If you have pounds of sugars and a whole bottle of extract and a whole bag of flour and a whole box of baking soda, but you only have, excuse me, 1 cup of chocolate chips, you're not making a full recipe. That because you can only make half a recipe. And so that's basically the idea behind limiting reactant. So most of the time in chemistry, we have more of one reactant than we need to completely use up the other. And a lot of times that reactant is said to be in excess. And if you read some of the problems that I've already given you, it states blah, blah, blah is in excess. The other reactant limits how much we get. Once it runs out, the reaction stops, comes to a screeching halt and says, I can't make any more. And this is called limiting reactant. We're not going to really learn anything new to answer these. Limiting reactant, you try all of the reactants, and you have to calculate for the same product, obviously, the one that you're asked to find. And the one that has the lower amount of product, again, the lower amount of product is the correct answer, because you're going to be limited by the smallest amount within the ratio that the recipe calls for. And so that's how you have to go through that. So here's an example. 10 grams of aluminum reacts with 35 grams of chlorine to produce aluminum chloride. Now, this only has one product, so there's no really choosing here. And so you have 35 grams of this. You have 10 grams of aluminum. And you want to know how many grams of product can get made. So one of these is going to limit that. And so you see you have gram unit, gram unit, gram unit. So you're going to need the molar mass of all three of these. And this is 133.5, chlorine 71.0, and aluminum 27.0 for 1 mole of that stuff. And so we do with aluminum, we do it with chlorine. We see aluminum is so much, not so much, but is somewhat larger than for the answer, aluminum chloride. Even though you're starting with less of it, because it weighs less, the mole ratios involved, you need more chlorine mole ratio-wise, chlorine weighs more. So therefore, chlorine ended up being the limiting reactant, and the correct answer is 43.9 grams. So be sure you mark out which one you know it's not. Double make sure that you are marking which one you believe it to be. And so, again, you figure out that chlorine was the limiting reactant. So here's another practice. If we have 15 grams of potassium reacting with 15 grams of iodine, calculate which reactant is limiting and how much product is made. So I put 15 and 15 above the two reactants, X above the product. I have grams everywhere. I know I didn't have room to write grams, so I didn't, but I have grams everywhere. And so I am calculating all 3 molar masses, and I have those on screen now. So I'm going to start first off with my 15 grams of potassium. So I am going to have grams of potassium down here, and that's going to be my molar mass step. And so 1 mole potassium and 2 moles of potassium. And I'm going to go to my product, make 2 moles of Ki. And now I'm ready to use my molar mass, which is always for 1 mole. 1 mole of Ki is 166 grams. I'm going to run out of space here. And that's going to give me an answer that with 3 sigs. I'm going to take 15 times 2 times 166, and I'm going to divide that by, and I'm going to use parentheses, 39.1 times 2 into my parentheses equals, and I have 3 working sigs here, 63.7 grams of Ki. Now I'm going to do my iodine. I have 15 grams of iodine. That means I need grams of iodine down here, so I'm going to use my molar mass of 253.8, and that's for 1 mole of iodine. 1 mole of iodine makes 2 moles of Ki, and 1 mole of Ki weighs 166.0 grams Ki. And so I get 15 times 2 times 166 divided by 253.8, and that gives me 19.6. So overwhelmingly, this is my limiting reactant. This is my correct answer. This is not what I'm going to use. And so I found my limiting reactant here. Again, you can recognize a limiting reactant problem because you're given more than one amount. You convert all the reactants to the same product, and the lowest answer is the correct answer. The reactant that gave you the lowest answer is the limiting reactant. And if you have to find more than one product, be sure to start the limiting reactant. You don't have to determine which is the limiting reactant over and over again. Number 5, we're probably not going to utilize too much. You are going to be assigned worksheet 4, sort of. I'm going to save the percent yields for another day. So we're going to work on 3 limiting reactant problems today.